Wow, you guys are ready. Okay. So, I said this before. I'm just going to repeat it. There's no product rule, no quotient rule, no chain rule for integrals. Okay. So we need another integration strategy or technique that can help us evaluate integrals that have a product, a quotient, or a composition. Now, you saw some in the past where you can just use some algebra 1 to rewrite it, and it turns into something that you can handle, right? Well, when that doesn't happen, again, you might need some other strategies, okay? So there are several integration strategies you haven't learned yet, okay? And so this is one of them. It's called what? U-substitution, okay? So you're going to use U-substitution. Actually, again, it's not always going to work. It's just another strategy you can try, right? And so anytime you have an integral that contains a product, quotient, or composition, U-substitution is something you might want to try. Okay? It might or might not work. Okay, so here's how it works. Okay, so this is something you're going to do off to the side of the problem. Okay? You let u equal one piece of the function. Okay? And now, what piece? Well, it varies. So here are some hints in choosing what you're going to let u equal. If you have a composition, it might help to let u be the inside of the composition. If you have a product of two functions, you want to let u be the more complex factor in a lot of cases, or if you can look at it and look at the two factors in the product, you might want to let u be the factor which when you differentiate it, you get the other factor. Okay, so these are just some hints that you might want to think about as you're deciding on what to choose for your u. If you have a quotient, usually what you're going to do, and again, this is not always, this is just usually. Usually you're going to let u be the entire denominator or the inside of the denominator. Okay, so once you choose a u, you're going to simply differentiate u with respect to x. In other words, just find du over dx. Now, I'll show you what I mean by this, but you're going to move the dx to the other side. And then after that, you're going to continue rewriting this to try and get it to match some of the other parts of your integral. Okay? Okay, when you're all done with that, you're going to substitute everything from step 1 into your integral so that there's no longer an x or a dx. Okay, it sounds complicated, but once I do a couple examples, it's not too bad. Okay, so after you've made all the substitutions, so there's no longer an x or a dx left in your integral, hopefully you'll be left with something you can integrate. If not, then obviously the u substitution you tried did not work. Thank you. And then you'll have to try something else. Okay, and then finally, step 4, after you integrate, you're going to replace a u with your expression from step 1 so that your answer will now be in terms of x. Okay, so let's look at a pretty straightforward example. Okay, suppose I ask you to integrate that. That is it's actually a product and a composition, isn't it? Yes? So what I'm going to do is, again, you don't have to do this first step, but this is what I did. I simply took that 2x there, and I moved it over here next to the dx. Okay, no big deal there. Okay, now, notice how this contains a composition, right? So letting u be the inside of the composition, I'm going to let u be that, right? That's the inside of my composition. And by the way, you guys, real quick, what's the derivative of that with respect to x? In other words, what's du over dx? Quick. 2x, isn't it? Isn't the derivative of that just 2x? And then technically, you can use algebra 1 here. And so to move the dx to the other side, I multiply both sides by dx. So if I multiply both sides of that by dx, I get that. Does everybody agree with me? Yes? Okay, so all I've done is off to the side, I let u be the inside of the composition. I took the derivative of that, and then I solved for du by multiplying both sides by dx. Are you with me? Okay, now watch what's going to happen. I'm going to go back to the original problem, which, by the way, was that, and remember, I rewrote it like that. So what I'm going to do is this. I'm going to replace that with what? Based on what I did here, I can replace it with what? I can replace all of that with what? If u is x squared plus 1, this becomes what? U to the what? 4. And notice I have 2x dx equaling what? Du. So can I just replace all of that with du? Any questions? Okay. Now, at this point, I have this, right? And I think that's a pretty easy integral to finish. And again, notice, I no longer have an x or a dx, do I? And that's a mistake you're going to make. You're going to do part of the substitution, but you're not going to finish it. So before I can integrate, everything's got to be in terms of u du. I cannot have any x's or dx in here. Is that clear? Okay, and then obviously, guys, you should all be able to integrate that. So what's, using the power rule, what's the antiderivative of that? Quick. Don't I get 1/5 u to the 5th over, plus c? And then finally, the last step is to what? Yeah, replace u with what it was back here. So if u was that, I can replace u with what? X squared plus 1. And so there's my final answer. Okay, so by making this u substitution off to the side and putting it back in, I had something I can integrate. And so therefore, that integral equals that. Any questions? Heads up. Okay, all right, thank you. All right, let's look at another one. This one has a trig function. By the way, I didn't do it on the first example, but I could have done this. Okay, I didn't do it on the first example, but I could have. It would have worked just fine. So what I'm saying is, from now on, I'm just telling you, I mean, it worked out fine without pulling it out in the first example, but let me just give you the advice to always pull out any constants in your integral before you do anything else. So, looking at the next example, what should you pull out of the integral before you do anything else? The 6. Can I pull out the 5 or not? No, the 5 is tied up inside of a trig function. Okay, you guys, I'm not asking you to bring the passes today simply because of the weather, but after today, you guys are going to have to bring them, okay? All right? All right, but anyway. So, all right, so all I did is pull out the 6. That 5 has to stay there, though, doesn't it? Okay, so I need to integrate this. Now, again, you can't integrate it with that 5. I mean, if the 5 wasn't there, then you wouldn't need a u substitution, would you? Right? I mean, you could all integrate cosine of x, but you can't integrate cosine of 5x. So what you're going to have to do is make a u substitution here. So notice that it's a composition. What's the inside, guys? The inside is what? 5x. So when you have a composition, usually the best strategy is to let u be the inside of that composition, which is 5x. What's the derivative of that, guys, with respect to x? What is it? 5. And then I just multiply both sides by dx to get from here to here. Okay? And by the way, I can also multiply both sides by 1/5 to get to here. Okay? So once I made the u substitution, I just took the derivative and then played around with it. Okay, so look at what we have now, guys. Here's the original problem, right? What can I replace that with now? I can replace that with what? If u is 5x, I can replace that with what? With what? Cosine of u. And now I can replace dx with what? What can I replace dx with here? 1/5 du. Everybody see what I'm doing here? Yes? And now, once I get to here, I can pull out the 1/5, making it a what? 6/5 out front, right? And then, at that point, I think it's pretty easy to finish. Everybody should be able to tell me that since the derivative sign is cosine going backwards, the antiderivative of cosine is just sine, right? And so I get this plus c, and then again, don't forget the last step. What's the last step? To put the u back in, what was the u? 5x. Okay, guys? Not too bad, is it? No. Okay. All right, I want everybody to try example 3 on their own. back. Okay, guys. So, again, I really didn't have to move that x, but I did, and you'll see why in a minute. If I didn't move it at the beginning, I might have realized to move. Yeah, I needed to move it later on. But anyway, so just know that it might help to do that. But anyway, so I need to integrate this thing, and notice I have a composition here. And so again, typically the best strategy there is to let u be the inside of the composition. So James, what am I going to let u equal here then? Okay. And then I think you guys can all tell me that the derivative of that thing with respect to x is what? What's the derivative of x squared plus 1, guys? 2x. And then you definitely want to move the dx to the other side by multiplying both sides by dx. And again, what I want to do is start comparing this. You see how I have x dx here and I have 2x dx here? You see that? So I don't want that 2 there, do I? So what I'm going to do is multiply both sides by a half. So now you can see I've got x dx here and x dx here. You see what I'm doing here to try and get the pieces to match so I can make a nice substitution? You understand that that's what this is all about? Okay, guys? So by moving that 2 to the other side, by multiplying by half, I can now replace x dx with what? 1/2 du. And then what can I replace this with, guys? That becomes what? Well, if u is equal to that, then I can replace that with what? U squared, can't I? Everybody with me on this? Notice how the x's, all the x's and the dx are gone, aren't they? I have nothing but u and du left, right? Correct? And by the way, I can pull that half out if I want, can't I? Yes? And do you all agree now I have something I can pretty easily integrate now and finish it up? Yes? So what's the antiderivative of u squared du? Quick. What is it? Come on, guys. What is it, Adam G? Well, what's the antiderivative of u squared du? Well, wait, u to the third over what? Yeah, over 3. Or 1/3 times that. You're right, same thing. Plus c. And so bringing down the half, it turns into 1/6. And guys, don't forget, the last step is to do what? Replace u. So what should I replace u with? X squared plus 1. Everybody agree that that's the answer? Yes or no? Yes? Okay, again, not too bad, was it? No. And yes, there are going to be a couple U-substitution problems on the final exam, even though you're not going to get tested on it separately between now and the final. There will be some of these U-substitution problems on the final exam in a couple weeks, okay? Got it? So again, make sure you're doing your homework, even though you're not being tested on it till, separately until second semester. It will be on the final. Okay. All right, so next one. Obviously, I'd like to get that 5 out of the way, and so that's what I did first here, okay? All right, now notice, this time I do have a composition, but bigger picture, I also have a quotient, don't I? Are you with me on that? Yes, that I have a quotient. I'm sorry, I have a quotient. And so when you have a quotient, usually you're going to let u be either the entire denominator or the inside of the denominator. Sometimes you might try one, it doesn't work. You try the other, and then it works. Okay? So again, there's no set rules. I can only give you things to try. Okay? Okay, so I don't know. Let's try letting u be the inside of the denominator. See if that works. Ready? Okay, everybody, what's the derivative of 1 plus 2x? Quick. 2. And then multiply both sides by dx. And then multiply both sides by a half. Okay. And I think you see the reason I did all this, because now I can replace dx with what? What can I replace that with, guys? Yep, 1/2 du. And then what about this? This becomes what now? 1 over what? U cubed. Okay. I'm just bringing the rest of it down. Any questions so far? Any questions? Okay, I'm going to pull that half out now, giving me a 5/2 out front, right? Okay. Now, you should all hopefully remember how to integrate 1 over u cubed du. And that is by making it what? Yeah, negative exponent. Okay, so once you rewrite it like that using Algebra 1, just use the power rule by adding 1 to the exponent, dividing by your new exponent. And if you simplify that mess, you get this. Negative 5/4. Actually, like that. And then don't forget to put your u back in, right? Does that look right, guys? Good? Okay, next page. Okay. Okay. So this time, again, notice I have a quotient, right? So again, in that case, try letting u be the entire denominator or the inside of the denominator. Well, in this case, you really don't have an inside of the denominator, so let's just let u be the entire denominator. Yes? Got it? Okay, so that's what I did. Quickly, guys, what's the derivative? Go, go, go. 3. And then move the dx to the other side. And then multiply by 1/3 to get dx by itself. Okay, so again, once I solve for dx, I can go ahead and replace dx with 1/3 du. Everybody agree? And max, what does this become? What can I replace that with? Okay, good. And then, guys, clearly I can pull out the 1/3, right? And then hopefully you all remember how to integrate 1 over u du. Isn't it just the ln, absolute value of u? Don't forget your plus c. And then finally, don't forget to put the u back in. Whoops. And again, just be aware that if I wanted, I could put the 1/3 up there as the power, couldn't I? Couldn't I if I wanted? Isn't that one of your log properties from Algebra 2? If I want, I can either leave that 1/3 out front, or if I want, I can put that 1/3 on the exponent here. Either way. Okay? Good? Okay. All right, now look at example 6. You actually don't need a U-substitution for this one, because you can use a little Algebra 1. Remember we did this in some of the past lessons, just before break. If you want, you can change that into what? Can't you break that up into x squared over x plus 5 over x? Can't you? And then simplify, and then you'll be able to integrate that without any U-substitution. So just know that you have an option here. Got it? Okay. However, just for practice, well, actually, no, I don't even think it would work with a U-substitution. So again, what I'm saying is, just because you have a quotient, don't automatically jump to U-substitution, is what I'm saying. Is that clear? I'd probably try some Algebra 1 first. And when Algebra 1 fails, then I'd probably move next to U-substitution. Are you with me or not? Okay, so again, does everybody agree here that I can use some Algebra 1 and rewrite it like this? Yeah, I thought this was one that would work either way, but it actually doesn't. So you're going to have to use the Algebra 1 method here. And then clearly, don't I get, using the power rule, I get that, and here this turns into this. So again, there was no U-substitution on that one. Okay? Got it? So again, U-substitution is nothing more than something else to try, right? It's just another strategy in your toolbox, right? Okay? But in this case, we didn't need it. Okay. Next one. All right, now look at example 6 and example 7. They're very similar, aren't they? But the fraction is flipped this time, right? Isn't it? And didn't we say that when the sum or difference is in the denominator, Algebra 1 won't help? I mean, you can't split that up like you did here, can you? No. So as close as they are in the beginning, the way you go about integrating is totally different. This one, you just used Algebra 1. This one, Algebra 1 will not work. So let's try U-substitution on this one. Ready? Okay, so what do you think we're going to let U equal? What do you think, Danny? What do you think we're going to let U equal here? X squared plus 5. That's right. Okay, so again, when you have a fraction, typical strategy is to let U be the denominator or the inside of the denominator. There's a composition there, but there's no composition there, so I just let U be the entire denominator. Okay, part, what's the derivative of that with respect to x? In other words, what's du over dx? 2x. Okay, and then everybody agree I should multiply both sides by dx to get it out of the denominator? And then everybody agree I should multiply by 1/2? Okay, all right. All right, so let's stop for a second. Any questions so far? Is this okay so far? Any questions? All right, let's start comparing. Ready? Let's start comparing this with this. Well, that x in the top, can't that x be moved off to the side? Can it? Algebraically? Isn't that the same thing, guys? Everybody agree if I put the x here, it's the same as having it on top? And so by moving it off to the side, you can see the match that I want, right? But you see the match there? I got x dx here and x dx here. Please, guys, keep your heads up. Kevin, please. Okay, everybody agree we got a nice match? And so I'm going to go ahead and make that substitution now. Okay, so let's do it. So I'm going to replace x dx with 1/2 du. And then I can replace all of this with what? Hope. What can I replace that with? 1 over u. Okay, good. And then from there, I can pull out the 1/2, right? And I think you all know that the antiderivative of that is what? What is it, guys? Shout it out. ln, absolute value of u plus c. And please, guys, don't forget to put the u back in. What's my u again? X squared plus 5. And by the way, you guys, I'll wait, and then I'll say what I'm about to say. Any questions on how I got that? Any questions? By the way, guys, no matter what x is, do you agree when I squared and add 5, it'll always be positive? Does everybody agree with that? That x squared plus 5 will always be positive no matter what x is? And so if I want, what can I do? Get rid of the what? Absolute value if I want. So if you see that as the answer instead, no big deal, right? Same thing, right? Everybody agree? Okay. All right, ready for a different kind? Okay, now again, when you look at example 8 here, clearly that's not something you can integrate, right? Everybody agree that's not something you can integrate? So again, anytime you have a product, a quotient, or a composition, chances are you're going to try U-substitution. So everybody agree you got a product here? Yes, so you're going to use U-substitution. All right, now you've got a choice. You've got actually 3 choices. Ready? You've got 3 choices for your U-substitution. Are you ready, guys? Please watch. Hope with me. Okay, I could let U be the tangent. I could let U be the secant. I could let U be secant squared. Those are my 3 choices. Everybody agree? I could let U be the tangent x. I could let U be secant x. Or I could let U be secant squared x. Everybody agree? Those are my 3 possibilities. Which one might work? Well, let me give you a hint. On something like this, you want to let U be the factor or the thing that when you differentiate it, you get the other part of it. So if I let U be tangent, for example, what's the derivative of tangent? Secant squared. Boom, that's what I want to do. Does that make sense? Yes? So you want to let U be the thing so that when you differentiate it, you get the other piece. Because remember, once I make the U-substitution, don't I differentiate off to the side? Don't I? So that's why I'm thinking like that. Is that clear? Okay, so let's do that. So I'm going to let U be tangent of x. And again, everybody, what's the derivative of tangent x? Secant squared. Okay, so once you do that, it's just the same steps, right? You move dx to the other side. Okay, and then stop for a minute and start comparing. Do I have my nice substitution? Yes? Do I or not? Do I have a nice substitution at this step? Yes. So I can replace secant squared dx with what? With what? du. And then I can replace that with what, guys? What's tangent x now? What is it? U. And I don't think you could find an easier integral, could you? I don't think so. What's the antiderivative of u du now, guys? What is it? U squared over 2 plus c. And again, don't forget to put the u back in. So I can replace u with what now? Tangent x. And by the way, the proper way to write that is like this, right? Okay. All right, good. Good? Any questions on U-substitution? Not too bad, is it? I mean, you just got to try something, okay? The more you do, the better you're going to get, which is why you have to do your homework, okay? I mean, it looks easy when I tell you what to let U equal, but it's a whole different story when you got to do a whole set of problems on your own or take a bunch of scrambled problems on a test or the AP test and you know, and decide on what you're going to do. It comes from experience. That's the only way to get good at this, right? Not by watching me only, but by watching me and then doing it on your own. Is that clear? Okay, so make sure you go home and do your homework when I'm done with the lesson. Okay, last page. All right, now again, we've got all kinds of choices here. I can let U be secant. I can let U be tangent. I can let U be secant tangent. I can let U be 2x only. I mean, there's all kinds of possibilities here. So let's talk about it before we choose a U. Are you ready? Let me ask you this. Suppose you were left with this. Would you be able to integrate any of these types of things with that 2x there? Would you? Would you? No. You can't integrate any of these. You could only integrate if it was x or u, right? You couldn't integrate it with that 2 there. Are you following me? So doesn't that kind of leave you with no choice but to let u be the 2x, doesn't it? So you can end up with like secant of u or sine of u or cosine of u, which is something you can integrate maybe. Do you understand why in this problem you're kind of forced to let u be the 2x, aren't you? Yes? Because you can't integrate any of these. Okay. I can't take this heat, guys. When I'm done, I'm going to go change into a t-shirt. Anyway. Okay. So notice then in this case, I'm going to let u equal 2x, right? Okay. So what's the derivative of 2x, guys? What is it? 2? Yes? All right. And then move the dx to the other side. And again, you guys notice you don't have a 2 on the dx, do you? So I don't want this 2 here. So what should I do with that 2? I don't. Notice, all right? I don't want that 2 there. I don't have a nice substitution yet. So what am I going to do with that 2? Multiply by a half here. Okay, so now can I replace dx with this now? You see what I just did there? Okay? All right, so let's do it. And then, by the way, what does the rest of this become, guys? That becomes what? Secant of what? U, then what? Tangent of u? Then what? Then what? Yeah, well, let me pull out the half. You're right, but 1 second. All right, now, is that something I can integrate? Yes or no? Is it? Yes, it is. Because we all know that since the derivative of secant is secant tangent, going backwards, the antiderivative of secant tangent is just secant, isn't it? Okay, so once I made those substitutions, it's actually pretty easy to finish, isn't it? And again, please don't forget to put your u back in as the last step. Okay, so there's my answer. All right, so let's finish these last two together. Okay, who wants to help me? If I don't have any volunteers, I'll just call on somebody. Who can tell me what might be a good strategy here? Let u equal what? Who wants to help? Raise your hand. Who wants to help? Go ahead. 2x minus 1. Okay, let's try that. Okay, all right, so if I let u be the inside of the composition, everybody see that's what he did? He let u be the inside of the composition there? Okay, what's the derivative of that, guys? Quick, everybody. 2. And then obviously I want to get the dx out of the denominator. I can never have it in the denominator like that, so move that. And then start comparing, okay? And by the way, let me rewrite the original problem over here real quick. Okay. All right, and then I can replace that with what, guys? Replace that with what? Whoa, what did I do? Sorry, that's dx. Sorry. Let me say that again. Again, I just rewrote the problem. Everybody good with that? Okay, so what can I replace dx with? Well, when you compare, I don't like that 2 there. Do you? Do you want that 2 there or not? Do you want the 2 there? No. So what do? I multiply by what? 1/2. Okay, so now can I make my substitution by replacing dx with that? Yes or no? Yes? Okay, so let's do that. And then I can replace this with what, guys? What's that? What do you think, Samia? What does that become? Yeah, square root of u. And then obviously I'm going to pull the half out, aren't I, to get it out of the way? Okay. All right. And then finally, is that something I can integrate? Yes or no? Yeah, by writing it as what? U to the 1/2. Can't I just use the power rule once I turn it into that? So don't I add 1 to the exponent and divide by my new exponent plus c? And then if I invert that and multiply by that, doesn't that turn into 1/3? And doesn't this turn into square root of u cubed, which turns into what? U square root of u. And don't you forget to replace the u. Got it? Okay, so put the u back in. Okay, no, I went kind of faster at the end. Any questions about what I did there? Any questions on that stuff? Okay, last one. Ready? Don't I always save the best for last? Okay, are you ready? Any questions? Again, I don't want to go too fast. Before I do the last example, any questions on example 10? I know some of you look like you're still writing it down, but any questions? All right, now let's talk before we start the last one. There's actually two substitutions that would work. What do you think one of them is? Letting u be what? 2x minus 1. But I also believe you could let u be the entire square root of 2x minus 1, and that would work too. Okay, they both work. Okay, so we would just get lucky either way here that they would both work. It's up to you which way you want to do it. You can let u be the inside, which is the 2x minus 1, or you can let u be the whole square root. You know, that's up to you. What do you want to do? Which way do you want to do it? You pick. You pick. The inside? Fine. Okay, let's just do that. All right, now you take it from there. I'm going to go change. Okay, ready? Here it goes. Ready? Let me do this on separate paper so I don't have to cram it in there. Okay, so all right, so we already decided on a U earlier, didn't we? What is it? So off to the side, we're going to let U be the inside of the composition. We all know the derivative of that is 2, right? We all know to move the dx to the other side, and then, because there's no 2 here, by the way, why do I keep doing that? That's dx, okay. Okay, so, all right, so move that 2 to the other side. Okay, any questions so far? Okay, well, let's start making a substitution, then we'll talk about what happens next. So, clearly, I can replace that with that, can I? So that's what I'm going to do first. Okay, I can now clearly replace that with what? Square root of u, yes. Okay, and then this is still here, isn't it? Isn't it? Yeah. All right, now there's a problem there. Well, first of all, let me pull the half out. Let me do that. Okay, so here's the problem. You cannot have a mixture of x's and u's. Obviously, that's not going to work. It's got to be all u's and du's before I can integrate, yes? Again, I cannot have a mixture of x's and u's or I'm stuck. Do you agree with that? It's got to be all u's and du before I can integrate, right? Okay, so, well, we really don't have many choices, do we? But to try and play with what we have over here. I see an x here, don't you? So why don't we solve that for x and put that there? Won't that get rid of it? Won't it? Yes? Okay, so let's do that. So I'm going to take this thing down here. Okay, so to solve for x, I'm going to what? Add 1, then what? Divide by 2. Very smart, isn't it? It is. Well, it's true. Okay, so everybody see what I did? Yes? Okay, so let's make that last substitution there by replacing that thing with, yeah? Okay. Okay. Okay, and then what can I do with that 2? Pull it out and make it a what out front? A 1/4? Okay, so now we're left with this, aren't we? Yeah? Now, you might think you're still stuck. However, I think a little bit of Algebra 1 might come in handy at this point, won't it? Yes? Okay, and so, everybody see what I did? The 2 times the 2 gave me a 1/4 out front. Is that clear? Yes? Okay, so, a little Algebra 1. I'm going to distribute this times this and this times this. Just using some Algebra 1. Everybody agree that turns into what? U to the 3/2 plus U to the 1/2? Everybody agree? Algebra 1. So all I did is distribute. Okay, guys? So that step is just Algebra 1, isn't it? By distributing. Yeah? All right, now, guys, do you agree I have something I can integrate finally? Finally? I can integrate this now? Okay, so let's finish it. Okay, so I'm going to add 1 to the exponent, divide by my new exponent. Same thing here. Add 1 to the exponent, divide by my new exponent, plus c. And then just clean this up. Let's see, this becomes 2/5 square root of u to the 5th. This becomes 2/3 square root of u cubed. Okay, I'm going to distribute the 1/4 now. And by the way, this turns into what? That turns into what? U squared square root of u. And this, so you get 2 12s. This turns into what? U squared root of u. Okay. All right, now you can put the u back in at this point, and then again, if this were a homework problem, then you were checking the answer in the back of the book, or if this were a test problem and you were looking at the answer choices and this wasn't there, then there's one other thing you can do here. You can pull stuff out. In other words, what can I pull out of it? Again, what I would do now is I'd put the 2x minus 1 in back in, right, for u. So put the u back in. If that's not the answer, if it looks totally different, then this is probably what they did. What would be the common denominator between 10 and 6? I'm sorry, what would be the least common multiple, I should say? 30. Everybody agree it'd be 30? Okay, so I can make this what? 3/30ths, yes? I can make this what? 5/30ths, yes? Okay. And then what I can do is I can pull out a denominator of 30. What else can I pull out? A u and a what? Square root of u. Can I pull anything out of the 3 and the 5? No. And then you could put the u back in at this point, can't you? It is a little bit extreme, but I'm just saying that, yeah, it really doesn't matter where you put the c. I didn't mean to do that. It really doesn't matter where you put the c. Okay. And then so we get I get what? 3 times what? 2x minus 1 plus 5, and what does that mess turn into? 6x minus 3, which turns into what? 6x minus what? 6x plus 2. And then if you want, you can pull out the what from there? The 2? Yeah, I know. This is crazy, but it's just algebra. Yep. And so now you can pull out the 2, can't you, from here? And you get 2/30ths, which becomes a what? 1/15th. Okay, so there is one more step you could do there, right? I ran out of space, okay? Good? Will there be one this nasty? I don't know. Maybe. Maybe not on the final, but on that test, the first test you're going to take second semester on this stuff, yeah, there'll be one like this. But maybe not on the final, though. I don't remember. I probably didn't put one like this on the final simply because it's so time-consuming. Okay, but fun, isn't it?